Hello everyone, welcome to Database Analytics. Till now, we have studied Generative Adversarial Networks or GANs and its implementation right from scratch. You all know that GANs are a major breakthrough for generative modeling, right? Even after this, training GANs is a difficult task. Hence, in today's session, we will be studying the challenges with GANs along with some tips and tricks. The first major challenge is that the discriminator overpowers the generator. Now, in this case, the signal from the discriminator's loss function becomes too weak to drive any meaningful improvements in the generator. In this case, the discriminator does not provide any valuable feedback to the generator, and hence the generator will not improve. So let's observe this particular image. Now this is a training snapshot which I have captured. In this worst case scenario, the discriminator perfectly learns to separate real images from the fake images, and the gradients vanish completely, leading to no training whatsoever. Now, if we want to solve this particular problem, then we need to weaken the discriminator. We can use some tips and tricks to make the discriminator weak. The first trick that we can use is increasing the rate parameter of the dropout layers. Now this will dampen the amount of information that flows throughout the network. The second thing that we can do is reducing the learning rate of the discriminator. Then we can reduce the number of convolutional filters in the discriminator. Also, we can try adding noise to the labels when training the discriminator. We can also try flipping the label of few images when training the discriminator. And this flipping will be done at random. The next challenge or the second major challenge is that generator overpowers the discriminator. If the discriminator is weak, then the generator will find ways to fool the discriminator. The generator will find small sample of identical images which fools the discriminator, and this condition is called as mode collapse. For example, suppose we train the generator over several batches but without updating the discriminator in between. In this case, the generator will try to find this single observation, and this single observation is also called as mode collapse, or simply a mode that always fools the discriminator and will start to map every point in the latent input space to this particular image or mode. Now the result of this is this particular image, that is the gradient of the loss function will collapse to 0, so it wouldn't be able to recover from this particular state. Now even if we try to retrain the discriminator to make it strong and not getting fooled by the generator will simply find another mode or another image that fools the discriminator, since it has already become numb to its input and therefore has no incentive to diversify its particular output. We can solve this particular problem by strengthening the discriminator. So we can use the following tips and tricks to make the discriminator strong. The first trick is to reduce the rate parameter of the dropout layers. The second trick is increasing the learning rate of the discriminator. We can also try increasing the number of convolutional filters in the discriminator. We can add less noise or no noise to the labels when training the discriminator. Also, we can prevent flipping of some images while training the discriminator. Now, the third major challenge is the information provided by the loss value during GANs training, which is also called as uninformative loss. Now we have studied in deep learning that we need to minimize the loss function, right? But this might not be the case. Why? Since the generator is only graded against the current discriminator and the discriminator is constantly improving, we cannot compare the loss function evaluated at different points in the training process. Now we can see in this image, we can observe that the loss function of the generator actually increases over time even though the quality of the image is clearly improving. Now this lack of correlation between the generator loss and the image quality sometimes make the training of generative adversarial networks difficult to monitor. The fourth and final major challenge with training of generative adversarial network is the huge amount of hyperparameters. Even with simple GANs, there are large number of hyperparameters to tune. As well as with the overall architecture of both the discriminator and the generator, there are parameters that govern the batch normalization, dropout, learning rate, activation layers, convolutional filters, kernel size, triad, batch size, latent space, and so on. And hence, these GANs are highly sensitive to very slight changes in all these parameters. Finding set of parameters that works is often a case of educated trial and error rather than following an established set of guidelines or techniques. Hence, Understanding GAN's internals and interpreting the loss function is very important, or it's very crucial. It helps to recognize the adjustment to hyperparameters that can enhance the model's stability and robustness of the model. So that's it guys for this video. Hope you have got something new to learn. If you have watched this video till now, do like this video, comment on this video for your feedback and subscribe to the channel DataFuse Analytics. Thank you guys.